Hi, in this video we'll talk about artificial intelligent architecture. So let's talk about artificial intelligence. There's multiple streams. There's machine learning, there's predictive modeling, there is automation. Let's lightly touch on some of these aspects. Let's talk about machine learning. Machine learning is a driver of data analysis that will enable you to predict a trend or provide some clarity to a trend. Machine learning, under the covers, requires a lot of data to be relevant. You ever heard of big data? So machine learning requires a lot of data, and there requires in that data a lot of repetitiveness in that data. And then what machine learning can do is it can pattern recognize those repetitiveness aspects of the data, and then it can formulate some type of trend, or at least indicate to you some trends from that pool of data. On the other hand, there's also statistical modeling. Statistical modeling does not require a lot of data. It requires just a sample of data that might represent a population. And the idea here is, under the covers, you find different samples that you can compare with, either two comparisons or multiple comparisons of samples, and then you try to generalize to a population, and you use some statistical methodologies to support that. Let's talk about another aspect of artificial intelligence, which is automation. The concern with automation is people assume that if we automate processes, that would replace people. We design artificial intelligence systems to minimize human intervention, but only in those cases where human intervention is a task that's adverse to the human. So what that means, for example, is people have a lot to bring to the table. They have a lot of value, a lot of strengths. If they're engaging in activities that's task adverse, then that's not appealing to them, and it's not appealing to the productivity goals. So we develop these artificial intelligence systems to replace only those tasks that are highly repetitive or task adverse. So I'll give you an example. I built a system that is a reconciliation system for a company. The idea behind this system was that it would automatically reach out to external systems to pull data. Then it would normalize that data so that we can have some type of pivot to compare the data set to correlate with each of these external systems. Then likewise, we would also correlate that data by normalizing it with the ledger. So from there, how do we enhance this to minimize human intervention? And let's say there's an outage, or let's say in the supply chain, a box broke and that implicated some outcome. So when we have this data, we incorporate artificial intelligent algorithms to understand the root cause of these situations so that we can anticipate them, alert and notify the right people at the right time so that they can focus their attention in the right place, rather than people focusing their attention only on the superficial outcome of an issue and dealing with that, rather they're focused rather on the root cause. Likewise, when we're comparing this data in the ledger and we're reconciling, we engage the right people to make those decisions on how to reconcile those situations. So as you can see, an artificial intelligence system can have value when we have people focusing on the right things at the right time to help them be more productive. So it's not about replacing jobs, it's about enhancing people's experiences, enhancing their productivity. So let's talk about one singular process and break it down. So you have a process. To make this automated, you just need a trigger. The trigger could be a trigger of time, or it could be triggered by some other event. But essentially, you need a trigger. That trigger then if the right data is in the right place, that process will produce an outcome. So the idea then, to make this an artificial intelligence system, is you can piggyback off of existing processes to trigger a process to begin executing. But we just don't stop there. To make it more meaningful, we chain these processes together. What that means is we'll have one trigger to have one event to trigger a process, to execute, to provide an output. That output becomes the input for another process to trigger, to execute, to provide some output. And we use the output from that event and that result to trigger another process, thus chaining all of these automated flows to be chained together or piggybacking off of existing flows. This then contributes towards a notion that we have in an artificial intelligence system. At least this is a trend we have for now. This does not mean we have an artificial intelligence system. It's emerging to become one. What is the whole goal of having an artificial intelligence system? Is it to just replace people and minimize human intervention? I'd like to suggest that we are collectively moving towards a direction of building a knowledge system. A knowledge system is something a little bit more relevant to the whole purpose of why we need intelligent systems or artificially intelligent systems. So we're developing and moving towards a knowledge system. So all of these architectures in artificial intelligence, all these aspects, why are we talking about it? So we bring up some aspects of machine learning, some aspects of predictive modeling. We touch on statistical models. We're talking about being able to make better informed decisions. We're talking about automation. So if we mix all those together into a hybrid approach, into a solution, we are actually going to contribute that towards what's known as a knowledge system. So this will become the upcoming trend. Right now, we're still trying to mature artificial intelligence, but once that becomes a little bit more mature, and so when we have a knowledge system, we actually incorporate some of these artificial intelligent capabilities, but also with the understanding of what our end goal is, of what our objectives are, and then being able to have a better understanding of what it is we're actually trying to achieve. And then ultimately what would be nice is to incorporate other factors into the mix, such as how do we become more efficient in this processing. So for example, if we look at the brain is highly efficient. We don't appreciate how efficient our brain is and how efficiently it operates. We don't incorporate that into our artificial intelligent methodologies or design. Anything you engage in, you're not 100% engaged in that activity. There's spurts of moments where you're engaged, but most of the time your mind is wandering and thinking about other things. And then you're able to get your focus back to be able to refocus on the objective. You might feel that your brain isn't really helping you. It's always going off on tangents when you're trying to do your work. But really, your brain is helping you. It is being efficient for you. Because if you were to really focus on a task at hand and 100% just being able to burn all the energy in your brain, you would be tired within moments. If you look at synapsechain.com, that's what we are trying to showcase. This platform is highly efficient and it tries to appreciate how efficient our brain is and incorporate that fundamental in this design. So please visit synapsechain.com. We'll have some other videos talking further about artificial intelligence, and we will also have some videos on knowledge systems and what they are.